All right, in this video, we're going to look at long division. So this is part 2 of section 4.7. So this is 4.7, part 2. You know, you learned in class about how to divide by a monomial. This is dividing when you have more than one term, when you have two terms, like the k minus 2, okay? All right, so the way to think about this, it's like what you're being given right here is a division problem written using the old-fashioned, way of dividing. But it's almost like you had this polynomial and you're trying to divide by k minus 2, okay? And see how the degree on top is 3. The degree on the bottom polynomial is degree 1. The way I want you to think about this is that we're going to use division to rewrite, and when you're looking at that, think of it like an improper fraction. We're going to try to rewrite it as a mixed number, okay? So over here on the left side, I've got this large number I'm dividing by just 21. Since the number's bigger on top, that's an improper fraction. So it's like the long division is going to be used to rewrite this as a mixed number, okay? All right, so let's go ahead and do that. All right, so we're going to do a step or two on the one on the left, and then we'll do a step or two on the one on the right, and then we'll outline the process so that you kind of see what you need to do. Okay, let me change colors. I'm going to do it in red. All right, so when you do long division, it's been forever since you've had to do long division. What you learn to do, even though you're trying to divide 21 into 4,945, you kind of get a rough estimate by looking at how many times 2 goes into 4. So since 2 goes into 4 twice, your estimate is that 21 would go into 49 twice. And notice that I'm writing the 2 above the 9, okay, not above the 4. So that's the division step. And then after you do that, you multiply the 2 back times the 21 and you get 42. Okay. Let's go that far with this one over here. We're going to do the same thing. When I was looking at this one, I was thinking about dividing 2 into 4. Okay. Over here, I need to think about, and I'm going to actually write it over here to the side. I need to think about dividing 3k to the third by k. Sometimes when you're dealing with the polynomials, the ones with the variables in them, it helps to see that scratch work, because then you can see how one of the k's is going to cancel out and you'll just get a 3k squared. That's what 3k to the third divided by k would be, okay? So I'm going to do kind of like what I did on the numerical one, and I'm going to write that over a space, and notice I'm going to be lining it up with the k squared term. All right, now what we did after we got the 2 over here on the left is we did 2 times 21. We multiplied those and got 42. So I'm going to do that same thing. I'm going to take the 3k to the third times k minus 2. When I multiply that, I've got to distribute that. I've got to multiply the 3k to the, that should have been to the second right there. So let me fix that. 3k to the second has to get multiplied by k minus 2. That has to get distributed to both of those. So that'll be 3k to the third minus 6k squared. Okay. So that gets written right here. 3k to the third minus 6k squared. See how the like terms are all lined up? All right, now when you handle the next step, it's not really confusing at all when you're dealing with the numerical problem. Next step is just subtracting. So we're taking 42 from 49, and that's definitely just going to be 7. When you're over here and you're doing that subtraction step, you got to take and remember that you're subtracting that polynomial. So remember that how when we were subtracting things vertically and you're subtracting that polynomial, it helps to think about distributing that, like it's like there's a -1 here. And what I asked you to do is to think about distributing that -1. So let's go ahead and do that. So when I multiply 3k to the third by -1, it becomes negative, and the negative 6k squared would become positive. So it's because I'm getting ready to subtract. So it's like I'm distributing the negative throughout so I can subtract straight down. So then this would be 0, and I'd have 8k squared that's negative and a positive 6k squared. Do you see how that's going to be -2? -2k squared. This is where mistakes are typically made. I want that circle going around both of it. Right here, people will put -14k squared or a positive 2k squared. Not getting the correct thing at that step is the typical mistake, and it's usually because subtracting polynomials can be a little tricky. Okay, so when we did the numerical case, we divided and got the 2, then we multiplied back and got the 42, and then we subtracted and got the 7. All right, after we do that, you're going to bring down the next term, next digit here, which is a 4, and over here you're going to bring down the next term, which would be the plus 2k. Okay, and then we just do that same series of steps over and over and over again. And students who work at this really get very good at it. It's very impressive. Okay. All right, so let me jot down the 4 steps again. The first thing you're going to do is divide. Second step we're going to do is multiply, and I'm going to add the word multiply back so you remember. It's like you're multiplying that 3k squared got multiplied back times the k minus 2. Okay. All right, and then the third step was to subtract, but let's say just a little bit more there. Subtract by changing the signs and adding the like terms. Okay. And then the fourth thing we did is bring down the next term. Next number on the numerical example, but it was the next term over there. And then what we do is we do that again and again and again until we're done. Okay. All right, so let me do the next round in a different color. Let's do this one in blue. All right, so now what I focus on is the 2 going into the 7, and it goes in 7 about 3 times, so I'm going to estimate that 3 would work. It's not always correct, if you remember way back when. That's your guess, and then you try it, and sometimes it's too big or too small, and you have to adjust. Okay, so when I get the 3, I'm going to multiply back, and I'll get 63. Okay, and then I'm about ready for the subtraction step, but let me go that far with this other one. So now I'm going to be looking at the k going into the -2k squared. So -2k squared, trying to divide by k, and that's going to knock out one of the k's, and I'm going to have a -2k left. Okay, so that's kind of like the 3 we got. So that -2k is going to go right here on top. And then we took the 3, we multiplied back by the whole entire 21. That's what we're going to do here. We're going to take that -2k and multiply back by the whole entire k minus 2. And that involves distributing. So you'll get a -2k squared plus 4k. This is kind of the scratch work you can do. Some people just do it from here. They'll take the -2k times the k minus 2 and get their -2k squared plus 4k right there. Okay. Now we're at the point where we're supposed to do the subtraction. So with the numbers, there's not a big issue there. People do that really well. I'll do that. I'll wind up getting 11. Over here, when I do the subtraction, I'm subtracting a polynomial. So it really helps to do that. I'm going to change colors here. To do that by thinking about if you're subtracting this polynomial, it's like you've got parentheses with a -1 out in front. So you can distribute the -1, and that's going to change these signs. And then you can add straight down. And see how the -2k squared and the +2k squared would add up to be 0. And then here we have a positive 2k and a negative 4k. So we're going to get a negative 2k at that point. Okay, negative 2k. All right, so now we're at an equivalent place on each of these, and we're ready to bring down the next number over here. Let me switch it to green. I'm going to bring down the 5. Okay, I guess I would, let me not change it quite yet so it matches what I was doing before. So let me go back and keep that blue for just a little bit longer. I'm going to bring down the 5. And over here, I'm going to bring down the next term, which is 10. Okay. And then I go and I try to divide again. So this time I'm thinking about dividing 2 into 11 on the numerical one. Here's where I want to be in green. 2 goes into 11 5 times, so that's my estimate. And then I multiply back and I get 105, I think. 20, 100, yeah, 105. Okay, so I'm going to subtract, and I'm going to wind up with a remainder of 10. Okay, so let's go over here and do that. So we're at the divide step. So we're going to take the k, and we're going to divide it, this k, divide it into the negative 2k. That's going to give me just negative 2. So I'm going to have minus 2 right here. Okay. Now when we multiply back, we get a negative 2k plus 4. Okay. Now over here, I just am going to be subtracting. There's no issue. Here I'm subtracting, but it's a polynomial. So what we're going to do is come in and change the signs. Otherwise, you mess up on your positives and negatives. So if the sign was negative, it becomes positive. This one was positive, it becomes negative. Now when I add, I can see that these add up to be 0. And I wind up with 10, take away 4. That's going to give me a 6 at that point. Okay, let me move this over a little bit. And that's my remainder on that one. Okay, that was not a negative there. All right, so now we're to the point where we need to know, well, how do we write our answer? So I just want to do a couple simple examples. If you had, say, 6 divided by 2, 6 divided by 2, that's an improper fraction. You could do long division. 2 would go in there 3 times. You would get 6, and there'd be no remainder. So you would just say 6 divided by 2 equals 3. That's an improper fraction, but it turns out to be a nice whole number. But if you had 7 over 2 and you did your long division, it would go in there 3 times, but you'd have a remainder of 1. And so that 7 over 2 is a mixed number. It turns out to be 3.5. So see how the 3 is the quotient, goes in front. The remainder 1 goes on top. And then what you're dividing by is the denominator. Okay, so that's what we're going to do on these. So this problem turned out to be 235. And, in the olden days, when you were really little, you would just say remainder 10. Okay, then you learned about mixed numbers, and you learned to do 235 and 10/21. Okay, and you even use that language. Right there, you say and. Okay, we're going to have to actually write a plus sign when we're dealing with polynomials. So your answer on this would have been the 3k squared minus 2k minus 2. That's the polynomial. That's the quotient when you divide the polynomial by k minus 2. And then you put the remainder over the divisor. But because we have variables in here, we actually need that plus sign. Here we just say the word and, but we don't actually write it. Like here, I would say 3.5, but we don't write it. But when you do it with the variables in it, you put that plus sign. Okay, so this right here is your quotient. This is your remainder. That's where it goes. And then this is what you were dividing by. That's called your divisor. Okay, so basically I think of it like that. I think of this problem where I was trying to do the division, I think of it as an improper fraction. It's like the degree on top is bigger than the degree on the bottom. And my job is to try to write it as a mixed number. And so the quotient plus the remainder over what you were dividing by. Okay, so I'm going to stop this and then I'm going to do 2 more examples in a different video. But this is kind of the basics of long division. It's very doable. My students who work at it really get very good at it. You've just got to be confident that you can do it and then just work at it until you can. Okay.